dimensions away from the mean you are. So the mean would be 0. It's 0 away from itself. Ooh. Right? Then you go up 1, down 1, up 2, so forth. All right. So given that situation, what's the probability I would get a z-score less than 1.51? Well, you just look up 1.51. That's how you piece these things together. And you get 0.9345. So this chart always tells you the area below the z-score that you look up, which makes a problem like this a little more complicated, but still, the probability the area is between the probability that it's between these two things. Look up 1.98, look up 3.21 negative, and then subtract those to get the area in the middle. That actually makes physical sense. That's awesome. If you let it be. Never subtract z-scores, because then you'll be somewhere else. Okay, I like it. You know, like, that sounds good, Jeff. I'd rather be somewhere else. No, it's not magic. All right, so we're going to finish this sheet out. These are if they're already z-scores. So the next part is, what the hell do I do when I don't have z-scores? Let me give... So we're going to do this part together, and then I've got another little handout that you guys are going to work on. Did I already put it over there? Yes. Okay. Yes. I like it. All right. Let's see. This is weird for me. Sure. All right. So what goes right in the middle of this? If you read through this little setup, what goes right in the middle? 31.64. That's the mean. It's normally distributed. The mean is in the middle. It's symmetric across the mean. And I want to know the probability that it's less than 27.2 minutes for somebody to find a parking spot over a week. So where's 27.2 minutes on that picture? Down here, right? Somewhere down here. I'm just going to put it over there so I have room to write it. You don't have to have perfect scale. Just please put it in the right place related to 31.64. So these are what are called raw scores. We have not processed them. We haven't put them through the z-score machine yet. So these are raw scores. These are X's. How do I make them into z-scores? I'll do this one. How do I make this into a z-score? What's the z-score formula? Anybody remember? Yeah, so z, x minus the mean divided by the standard deviation. I like it. So this little dude is going to rule our life for most of the chapters left. Oh shit. This guy's own chart is all, he's feeling pretty important. Because he is. He's flipping important as hell. Right? The z-score is how we measure distance in statistics. And the further you are away from what you expect, the less likely you are. So it's related to probabilities also. Let that sink in. Okay, okay. So if I make this into a z-score, if I make my raw scores into z-scores, they become problems just like these. Which means they're just, I have to look them up on the chart. And that's it. So let's see, what in this case, how do I make 27.2? Fill in this formula for me. 27.2, that's the data point I'm curious about, minus, what's the mean? 31.64 divided by 7.81, that's the standard deviation. Let me write that again. 27.2, that's the score I'm interested in, minus 31.64, that's the mean, divided by 7.81, that's the standard deviation. So do that for me. And by the way, where am I shading up here? What's the question asking for? Where do I shade? Below it. I like it. So I know the answer is going to be less than 50%. You know, like, that's good for you. But of course I do, because it's The middle cuts it in half, and that's way smaller than 50%. So now, what are you guys getting for the z-score? Let me catch up to you. Negative 0.57. Why do I round it to two places? Why do I always round a z-score to two places in this class? Because the chart only goes out to the second place. Isn't that amazing? I like it. Now, in general, if you've taken stats before, your teacher said something differently than me, I don't give a shit what's about it. Right, so I always have somebody tell me, he says push buttons in normal PDF and blah, blah. No, all right, you don't understand shit then. So our answers will always be a little off from the actual reality because we're rounding our z-scores. But by making you use this chart, you start to internalize how things are distributed without even realizing. So I'm really sorry. We're not going to just push buttons and get answers. If that's what you're hoping for, you need to leave college. If you find teachers like that, you need to get them fired somehow. Help me out. Trying to make America sane again. So our z-score is negative 0.57. Damn, Jeff, you're on a ranting mood. Yeah, this is true. Negative 0.57. That's our z-score. So if I give you raw scores are things with units. Z-scores don't have any units. So minutes, years, whatever. You first make everything z-scores, and then you look it up in the chart. Right? So my z-score for 27.2 is negative 0.57. How do I find this area then? How do I find that area down there? Look it up in the chart. Yeah, I love it. You guys are like, do what you just said, Jeff. But there's a lot of people not really paying attention. They're sort of here. Their eyes are open. So if you look up negative 0.57 in the chart, so you need a negative side. Look at negative 0.57. What do you guys get? Say it one more time, sir. 2843. If you cannot find that number, let me know now. Don't feel like, I don't want to let you know. I'll feel embarrassed. Screw that shit. Get it clear now. So negative 0.57. That's the second decimal place here.
Okay, I was doing this.
Ah, okay. Everybody else is good, right? Or accepting that you're not good. Something, one of those two. Which doesn't make sense. Make sure you can find that 0.2843.
That's the final answer.
Yes. Why is it the final answer? Because it asked me for less than 27.2, and the chart always tells me the area below. If they would have said more than, I would have had to do what? Do 1 minus this. The whole thing is 1. If they wanted more than, I would do 1 minus this to get this side. Oh, the 1 minus shit. I was trying to get you ready. If I know the opposite, I do 1 minus to get the thing I want. So in number 2, that's exactly what's going to happen. I want more than 53 minutes. So in the middle again is 31.64. Where's 53? Yeah, way the hell up here somewhere. I want more than that, so this little tiny area there should be kind of a small answer. So what's the first thing I've got to do here after I drew that picture? What do I do? Yeah, change 53 into a z-score, because I can't use the z-score chart unless I know the z-score. That only makes sense. I like it. So that z-score chart translates z-scores into probabilities. That's what it does. So real quick, let me show you a visual here. If you're not here, then just listen to me. So the mean cuts it in half. So that's 0.5. So down here, what percentage would this be? That would be really small. You with me? So as you move along, what should happen to your probability? If I keep getting bigger and bigger z-scores, the area below it should be getting bigger and bigger and bigger. So if you look at your negative z-score charts, don't the numbers get larger and larger as you approach 0? And then once you're past 0, you start getting bigger than 0.5. So that's what the z-score chart does. It says, wherever you are at the moment, here's how much area you've passed. So as you get bigger and bigger z-scores, you pass more and more area. Craziness. At the ends, do you notice how at the big, like negative 3.5, negative 3.49, negative 3.48, do you see how they're not changing very much? That makes a lot of sense because the height's very small. You're not really changing. In the middle, it's going to change a lot because it's really tall. You are adding and subtracting big amounts of area as you move around. Maybe. Possibly. Okay. So for this guy, to make z-score out of this, 53 is my data point, minus the mean, divided by standard deviation.
2.74.
Yeah. 2.7. Ooh, I like its ascension. 2.73, yeah, because the next number is a 4, yep, okay. 2.73, that's my z-score for this guy. So how do I find the area up here? Well, if I look up 2.73, I get the area below it. So when you look up 2.73, what do you get? I'm sorry, do it again. 0.9? 9? 6.8. But that's not my answer. That's not the part that I have shaded. So how do I get the answer? 1 minus that. Yeah, it should be remarkably tiny, right? Look, guys, look. So the average is 31, or almost 32. And the standard deviation is 7.81. So I expect it to be close to this. In fact, I expect it to be within 2 standard deviations. 2 of these is almost 16. So I expect it to be up to like 48 at most. This is asking the probability is more than 53. Do you see how everything kind of comes together here? What's the highest I expect it to be is 2 standard deviations up from the mean. That's almost 48. And the question is, what's probably more than 50 freaking 3? Well, that's unexpected. That's why it's such a small probability. So this isn't just plug shit into equations, get numbers, put it down, keep going. Make sure you can make sense out of your answer. Okay, maybe. And I don't mean that it's 0.0032 versus 0.0035 or something stupid. I mean, it's small. That makes sense. That it's so small. It's so freaking far away already. It was probably even further away. No. Probably I find a dude that's more than 7 foot 8 inches tall. That's going to be really unlikely, right? Okay, good. Same idea. All right, so what about this guy? So again, middle is 31.64. I want between 15.5 and 29.5. This is going to be a lot like this problem. The only difference right now is these are not z-scores. So the very first thing you do is you convert each of those into z-scores. So go ahead and do that. Convert those data points into z-scores. I'll do the middle. Yeah, I'm done. Sorry. Yeah, it's funny the first time, Jeff. Let's see. What z-score do you get for 15.5? 2.07, I like it. And then for 29.5? Negative 0.27. I like it. So there they are. The biggest mistake people make is they forget the parentheses. Order of operations comes in and kicks your ass. Right? What sucks about this notation is we know what this means. The calculator doesn't know that that's a big division bar. So you got to tell it there's a top and a bottom, calculator. You ain't got eyeballs. Let me help you out a little bit, calculator. I don't want to have eyeballs. That would freak me out. Okay. So now what do? I change those into z-scores. What do? I bet you it's related to what we did over here. Once we made it a z-score, we looked it up in the chart. So we got two z-scores to look up in the chart. If I look up negative 0.27, why is that not the answer? Because it's two. If I look up negative 0.27 for this guy, why is that not the answer? Because that area is too much. It's including this area down here. So I better look up that area too for the other z-score so I can subtract them and get the area that's my question. Get the area in between those two. Please let that make physical sense. It's not just a math abstract idea. It makes complete physical sense. Oh, the area in here. Well, I know the area here, and now the area here and here. Well, subtract and get the area in here. That's the idea. I love that shit. So what do you get when you look up negative 0.27 in the z-score chart? Got to try to trust you guys. Negative 0.27, what do you get for the area? Say again? 3936. Sounds about right. Is that what everybody else got? Okay.
Yes.
And then negative 2.07. I don't mistrust Jews here. It's just nice to have crowdsourced. All right. Negative 2.07. 0.192. And again, if you are not able to get these numbers, why are you not asking me right now where those numbers came from? You're going to have to be able to do this on your own. I'm not just making that shit up. That'd be really weird. How are they able to make the same number up? No. So hopefully everybody sees where those numbers are coming from. And then what do I do with those two crazy numbers? Subtract them to get the area in the middle. 0.3936 minus 0.0192. 3944.3844. Is that it? 0.3744. Shabbat. How we doing, guys? Let me just show you something. Look up here. We looked at this once before. The distributions. You remember that's where that binomial CDF stuff is? That you are not allowed to put on the homework as part of your work. People, you can check your work, sure. So I'm going to check my work. If you hit second distributions, you can do normal. I want CDF, because for this problem, I want from 15.5 to 29.5. So I want, in fact, we almost always use CDF for this. You don't have to know how to do what I'm about to do. So what's the lower bound? 15.5. What's the upper bound? 29.5. What's the mean? What was it? 31.64? And the standard deviation was 7.81. Let's see what it tells me. 0.3727. So why did we not get that answer? Because we rounded. No worries. So what? Calculator's more precise. Well, of course it is. Shit, we're just human. All right? We did pretty good on our own. Okay, maybe. Again, everything I just did, you don't have to know how to do it. It's on the calculator handout thing, if you want to see it. All right, any questions on those three problems there before we do this last one? So notice this. Let me see if you guys get this. If I start with an X score, a raw score, I convert it to a Z score, and then I look up the area. So this is a formula, the Z-score formula, and this is a chart. Does that little thing make sense? Give an X score, a raw score, minutes, years, centimeters, whatever. Change it to a Z score, look it up on the chart. When am I allowed to use the chart, though? What's the picture at the top of the chart? I'm only allowed to use it when I have a... What's the picture on the top of the chart? I can only use it when the distribution is normal. That's why I know all that shit so good. What could a distribution look like? And then this chart goes, I don't know any shit about that. It's got to be normally distributed for me to know everything so well. That's a big restriction, and that's why those numbers work. I can only use the Z-score chart to find probabilities when I have normal distribution. So better tell you it's normal, or they better give you a way to determine. So it's a big part of statistics. Am I working with a normal distribution? There's got to be a way to test. In all these different situations, we're going to look at how do you tell it's normal? How can I know it's normal? Why is it such a big idea? Because I got all the answers if it is. They're all just sitting there waiting for me if it is. If it ain't, I can't do shit. Stats 2, you can do something we don't teach stats 2. Too bad for us. So we're going to hope it's normal. Okay. Now, this last problem is like these last problems up here. Notice, what do I give you? Percentage. The 14th percentile, so 14% below it. So I give you a percentage. So I'm going to do this whole thing in reverse. I love this little shortcut thing here. If I give you a raw score, you can make it a Z-score, look up the area. If I give you an area, you can look up the Z-score and convert it back to a raw score. Now, real quick, let me do a little side note here. Very little algebra in this class, but if you don't know algebra, you will suck in this class still, somehow. Here's a little bit more algebra. So here's the Z-score formula. This is good if I know X, mu, and sigma. On this problem, I'm going to look up the Z-score. So I'm going to know Z, mu, and sigma. I don't want to solve for X every damn time. Let me solve for it once, which explains why when you learn solving equations, you immediately learn how to solve equations with no numbers in them. You have to be able to manipulate variables to put a formula in a better format. How do I solve this for X? Yeah, yes. So what sucks about this problem is a fraction. What's beautiful about equations? You can kill fractions. So it'll mean multiply by the sigma. So you get Z sigma equals X minus mu. Add the mu. So let me write this. X equals mu plus Z sigma. That's going to be another little formula for our formula charts. Let that sink in. Remind me, what does the Z-score tell you? What does the Z-score tell you? The number of standard deviations, the number of these that a data point is away from the mean. So a data point is this many standard deviations away from the mean. Holy shit, if you read this in English, it's a note. It's a formula, but it's also a note. So I think I've told you this. Every test I'm going to ask you, a certain question will be on every test. What does the Z-score tell you? Right? Or I could say, what would a Z-score of 2.5 mean? And then you would say, that means the data point is 2.5 standard deviations away from the mean. Right? And I'm going to get about 40% of students will get that question wrong. And you always want me to tell you what's on the test. I'm telling you right now, that question is going to be on the test. And still 40% will be wrong. I don't understand. And this is a note. Z-score tells you the number of these away from the mean to get to a data point. So the number of standard deviations away from the mean to get to the data point. It's crazy. Okay. So what the shit do I do with that, Jeff? All right. Where would the 14th percentile be? Yeah, it's going to, here's the mean. The mean cuts it in. And this is supposed to only have 14% below it, so it better be down here somewhere. Why did I put the 0.14 up there instead of underneath or something crazy? Because what goes underneath? Z-scores. What goes up here? Areas. That looks like a Z-score. So I'll have people look up 0.14, they get the point whatever, the 4 decimal thing, they put it down, plop. No, this is not a Z-score. This is an area. So can you find the Z-score that goes with this area? Where are the areas on the chart? In the body, right? You're like, what are you doing, just wax on? No, they're in the body. Look, get 0.14 as close as you can get, and then see what Z-score that is. So you're kind of doing this thing backwards. You find the 0.14 as close as you can get, and then look out to see what the Z-score is. We've done this problem before on that first set of problems. Somebody got it? Bar on your bar. So what's the closest you can get to 0.14? Look at this shit. 0.1401. Now again, you're not looking at 0.14. You're not looking here. Because what is 0.14 is not a Z-score. It just ain't. It's an area. So what's the closest I can get to 0.14? I can get pretty damn close. What Z-score is this? Negative 1.08. So this Z-score is negative 1.08. I love you guys. So if you can look up a Z-score and get an area below that Z-score, you should be able to look up an area below a Z-score and see what that Z-score is. That's what we just did. If I knew it was negative 1.8, I would get about 14%. I know it's 14%, I should be able to look and see it's negative 1.08. I should be able to go both ways. What the hell do I do with that? What's the question? The max time. So I want to get an X. And I know that X is mu plus Z sigma. So I know the mean. I know the Z-score now. And I know the standard deviations. You could have just made this a minus, but I just wanted to go right along with the formula. Sure should be getting 23.2, roughly. Minutes, yeah.
I have a question.
Yeah.
Read the chart. Is it not negative 1.00? Oh no, never mind.
Here, yes, the second decimal place. That's right. Do you remember that problem with the fins and the? I just remember the fins, but the one about beer. How much beer they drank? They drank on average this many liters. I guess. Like, I remember clean after every test. On that test, there's a problem about the Finns, or I can't remember the Germans, or in the North. I can't remember who else I picked. I actually found that on Wikipedia. By the way, Wikipedia is not a bad website. I'm so sick of English teachers going down. Bullshit. Go to the source and then find us. Wikipedia is an awesome source locator. Don't just take it from the article. Go to the sources. You guys understand? It's like everybody goes, I can't look at Wikipedia. Screw that shit. It has an awesome source list at the bottom. Go to the sources. Sorry. All right. So I actually got those numbers from the source. I got those numbers from studies that have been done. But there were problems that said, what amount is 2.03 standard deviations below the mean? You did this formula without even knowing you were doing this formula, if you look back at that. You took the mean minus 2.0, whatever I said, times the standard deviation. You did exactly this formula. Maybe. Okay. Any questions on that sheet? I'm going to give you another sheet.
So that's the minimum?
Holy sheet. Huh?
That's the minimum?
No. Nope. That's the max time. Why did I say max time? Because every other time that's in here is below 23.2 minutes, right? So I want this dividing point right there. Right? I want to know what that becomes. Yeah. Maybe. So there's a very colorful side to this. Don't worry about that side yet. That's the next thing we're going to do. Do this side, the least colorful side. The one about rents in San Diego and New Zealand. I would love it if you guys work together on this, but you don't have to. These are the exact kind of questions I love to ask for quizzes and tests. See you next Tuesday.
Don't even worry about it. Let her get tickets. If that's what she wants to do, let her do it. Put the car in the Elmer's parking lot. Yes, you can. I guess.
Yeah, I'm not gonna be there for a month, I don't know how long to be gone.
That's what's that.